Hello everyone, my name is Hamid Azimi and I'm part of the TechnologyCatalogue.com team here at Ampelmann. Today we will be taking a look at two technologies that help optimize the movement of people and goods in the oil and energy sector. With me are Diederick, Nierstrasz from Ampelmann, as well as Norbert, Dolle from White Space Energy. Before diving into the presentations, I would like to raise 2 points. Number one is how you could access these technologies that we're going to discuss today through the TechnologyCatalogue.com platform. As you can see here, the TechnologyCatalogue.com has the modules, and within the modules, you can access the sub-modules. Each technology has a sub-module associated with it. For the motion compensated gangway systems that we will be talking today, and Ampelmann will give the presentation in a second about that, is within the logistic module and the sub-module offshore access and cargo solutions. The second solution or technology that we will be talking about today can be accessed through the digitalization module and the sub-module called integrated decision. The second point that I also wanted to raise here during this webinar is basically the ability for you folks to be able to ask questions throughout the webinar. And that is on the right-hand side of the screen, you have the chat box that you could ask your questions. Having said that, without further ado, I will hand it over to Diederick to take you guys to introduce himself and take you through the Ampelmann solution.
Yeah, right. Thank you, Hamid. My name is Diederick Nierstrasz. Good afternoon. I work for Ampelmann Operations, and I'm going to talk a bit about marine crew chain solutions. And before I do, I'd like to start with a company introduction movie. So, Hamid, can you start the movie? Yes, so that was a bit of an introduction to our company, or at least a lot of nice shots of working offshore. Ampelmann is providing a safe offshore access solution for both people and cargo. So we transfer people and cargo safely offshore, and we have been doing that since 2008. And fulfilling the mission of making offshore access as easy as crossing the street. So now in operation for almost 12 years, and so far we've made 6 million offshore transfers. And our company is based on patented motion compensation technology, and that's basically what we do. So we compensate the motion of the vessel, making it safer and easier for people to cross from a vessel to a platform or a wind turbine. We were operating mostly in the walk-to-work market, and I will elaborate a bit on that market. So Walk to work consists of a vessel with a gangway system, the ones you saw in the movie, and the vessel supports installation work or O&M work on either on platforms or offshore wind farms. But the platform, the vessel stays in the field. So every morning, the people are being transferred to do their work on offshore, so on the platform or on a wind turbine. End of the day, they're being transferred back, and they sleep on the vessel. And the vessel is also used as a warehouse, as a workshop. But most importantly, it has an accommodation function for the people to sleep. And after, I don't know, 3 or 4 weeks, the vessel goes back to port for crew change and for resupplying. So this has been our core market, but we are looking more into crew change solutions. Well, crew change, that's quite a large market. As you see here, there are over 60 million people being transferred offshore every year, and about 7 million of these people are being transferred near shore, so let's say 2 hours distance to a platform, and that's mostly being done by small boats, small CTVs, crew boats, but the majority of the people are being transferred further offshore, and so that's about 9 million transfers there. And this is quite a potentially interesting market for us. So this market is now dominated by helicopters. And with Ampelmann, we believe we can come up with a more cost-efficient and a safer solution in this market than helicopter transfer. That is quite a bold statement, but at this moment we are running operations in Baku, in Brunei, in Nigeria, where we actually are reducing the operational costs and with a clean slate and safety records. But we really believe we can bring something to this market. But before we do, as I said, this market is dominated by helicopters. So let's compare a vessel with a helicopter. And the biggest advantage of a vessel, obviously, it's bigger. So it has a lot of capacity, and it makes the cost per transfer cheaper. So that's obviously the biggest advantage, but also the safety records, as we had in Walk to Work, makes it a safer alternative than helicopter. Also, in terms of personal luggage, on a helicopter you're limited by the 10 kilograms of personal luggage. On a vessel you can carry a lot more, but also the vessel has deck space, so ability to carry some spare parts, some other mission critical equipment to prevent downtime or to solve downtime without needing any other logistics supply for that. And finally, if safety case allows it, you can do a full platform evacuation, basically with one sweep, get the entire platform empty and all on the vessel and sail away. Obviously, that's a lot more difficult using helicopters. But on the other hand, if you look at helicopters, well, one of the biggest advantages of a helicopter is the high transit speed. And also the entire infrastructure and all the logistics and operations, everything is already laid out for helicopter transportation. So trying to get your feet between the door for a new solution is quite challenging. And especially as the people who are already being used to helicopter transfers are not easy to get out of their helicopter. And finally, the operational window of a helicopter is quite decent. The biggest showstopper for helicopter flights is fog. And although it's not really well to predict, it doesn't happen that often. So usually for helicopter transportation, you can have an operational window up to or higher than 90%. So that's quite decent. So with a helicopter, we have quite a good competitor. And if we really want to shift the market from helicopter transfer to marine crew transfer, well, we have a good challenge on our hand, and we really need to do it well. So how can we do it well? I think, therefore, we are working on a new solution, and this is Meet the 7011. That's a new vessel, a high-speed vessel that's currently being built by Dahle. And basically what we did, we combined forces. So Dahle specialized in vessel design and manufacturing, and Ampelmann with a lot of experience in offshore access. Basically, these two combined have resulted in this 7011 with an Ampelmann S-type. And basically, to do very well in this crew change market and give a good alternative for helicopter, it needs to be fast in transit, but also comfortable for the people. And the moment we start transferring people, it needs to be safe and efficient. But first, look at the transit. Transit speed of this vessel is 40 knots. Anyone sort of familiar in marine business knows that 40 knots is a really high-speed vessel. So that's really a challenge to get a vessel up to this speed, and it can carry 150 people. So that's a lot of people on high speed. But downside of high speed can be that it's sort of impacting the comfort of the people, and particularly seasickness. Dahle has been working on implementing the X-bow in this vessel, and that reduces the chance of slamming, and that's quite uncomfortable. But it's been taken into account in the design of this vessel. But also looking at business class comfort level, and as you can see in the picture, it really looks like sort of the business class seats of an airplane with fully reclining seats and media entertainment system, but also an artificial horizon. So people tend to get seasick when they don't see the horizon. Together with TNO, Dahle has been working on developing an artificial horizon where the people who are sitting in the vessel constantly see the motion of the vessel projected on the screen. So that also really reduces seasickness. So with this part, we think we can cover speed and comfort level and make it really tempting for the people, for the workers offshore, to not sit in an uncomfortable helicopter, but really being laying back in these business class seats. On the other hand, the transfer, as I said, needs to be efficient, needs to be safe. We as Ampelmann have been developing a fully electric lightweight system. So it needed to be lightweight because of the high transit speed of the vessel. So every kilogram counts. And fully electric because we needed a very high motion response to the motions of the vessel. So the vessel that's sailing 40 knots is usually not very stable when it's standing still. So a lot of motions. So we match the performance of our system to the motion characteristics of the vessel itself, coming up to workability up to 3 meters significant wave height. And this is very important, having a high workability. With these 3 meters, we can cover quite a large range of wave motions, and we can get a workability in most areas up to 90%. And also there's been some development in reducing the DP footprint, so the vessel stays in the same position. And also on board is a gyro stabilizer. It's a gyro to cancel out part of the roll motions of the vessel. So this is not a sort of future music, but currently Dahle is manufacturing this vessel in Antalya in Turkey, and we as Ampelmann are at this moment manufacturing this system, and it needs to be ready by the end of 2020. And then we can bring the vessel and the whole setup to the North Sea, and we start first testing and then actually doing commercial work. But with this setup, we think we have the right tool on our hands to really start competing in this market and really provide a good alternative for helicopter transportation, and saving costs and increasing comfort and safety. But most of all, with this, we have the idea that we can sort of break through the chicken and the egg situation. So although offshore operators see the potential of marine crew change, they always say there's no vessel that can reach the speed, and no vessel builder is going to invest in a vessel because the operators are not willing to step over to marine crew change. But I think we are forcing the market to make a step, breaking through the status quo. So here's the egg, and now we are looking for the chickens. So that's basically the next step. So we're building this vessel and its test type at this moment, bringing it to the North Sea. And from the beginning of 2021, we're looking for customers. So that can be either large operators with a cluster of platforms, but it can also be smaller operators. So combining a few operators with a few assets, combine the logistics, share the vessel, and I think even in the next presentation, Norbert is going to give a very interesting presentation where I think part of their technology could also be used to maximize the route we're going to sail with this vessel. But we see a large potential here. So if you are a large operator or a smaller operator, or you are a logistics service provider, or in any way sort of interested in this concept and you want to hear more about it, or you want us to come by and have a discussion about it, my contact details are in the next slide. But for now, this concludes my presentation. So thank you for your attention.
Thank you very much, Diederick, for the nice presentation. We have basically a question from one of the audiences. I read out the question. Hi, Diederick. Please, I would like to know the S type for your system. They are compatible to use with FPSO. I'm writing from Ghana, and most operators are using FPSO.
I'm sorry, I wasn't able to really hear the entire question. So, can this system be applied on FPSOs?
Yes. So they want to know if the S type or your system is basically compatible to be used with FPSO, and the specific audience is asking the question from Ghana.
Yeah. Okay. Well, that's nice to have some interest from around the world. But indeed, this system can be used on an FPSO. We have quite some experience also landing from a vessel to another floating asset. In this case, FPSO, but we can incorporate the motions of the target vessel, the FPSO, in our control loop, so we can make a safe connection to FPSO as well. So indeed, I love to come by to Ghana and hear all about your project.
Great. Well, thank you very much for the response, and we'll try to now move to the next presentation by Norbert. Please.
Thank you, Hamid, and thanks to all those on the line for dialing in. I wanted to start with this particular slide and visual. One, because it's very applicable to the use case that I'm going to describe in a couple of minutes. But also just to give Diederick a pat on the back. I've been using Ampelmann myself in Brunei, and it's really a kind of a fantastic solution, fantastic technology. What I'll start off with is explain to you how we use artificial intelligence to support complex decisions in the oil and gas industry. And then I show you one example in the logistics and maintenance area. If you've played a game of chess before, and most of you, I'm sure, have done that, then you know how easy it is to learn how to play chess, but how difficult it is to master a game of chess, to become really, really good at it. And why is that? That is because every move in a game of chess is a very complex decision, a decision with very many options, with risks and uncertainties, with an opponent to take into account. So it's very hard to make good decisions in a game of chess, and that's what makes the overall game very complex. Now, business decisions are not that different from these moves in complex games. Business decisions, in particular in oil and gas, also have an awful lot of options, have risks and uncertainties, and also have competing business drivers. So there's always a tension between cost, production, and safety, which makes it very difficult to make quality, good decisions. But if you think about decisions as being moves in a complex game, then artificial intelligence is very well suited to support us in making faster and better decisions. Now, this slide is showing you a timeline of slightly over 20 years, going back to 1996 when IBM used a pretty powerful computer called Deep Blue to beat the world champion in chess. In recent years, this particular artificial intelligence has developed itself really, really fast, solving more and more complex games. And as you can see, IBM, Google, and Facebook are behind this technology. And one of the things to note is that previous algorithms, really up to kind of 2016, 17, learned how to play these games by just absorbing huge databases of historical gameplay, essentially becoming as good as the best humans. The more recent algorithms don't use historical data anymore, but they learn how to play a game and to master that game by playing against itself. And that's how they achieve what they call superhuman performance. They become better than the better humans. Now, Google, Facebook, and IBM obviously don't develop this AI just because they like to play games. They see an awful lot of real-life applications. For example, Google have used the same AI algorithms that they use to play Go, an Asian board game, to optimize the electricity usage in their data centers, which is a huge cost component for them. Facebook developed an AI bot that plays poker against tables of pros and beats them all the time. Now, if you can play poker and bluff your way through the game, then you can use the same AI to support you in complex negotiations or biddings. So there's a lot of these real-life applications, and we see those as well across the value chain in upstream, midstream, and downstream oil and gas. So we've done work and supported complex decisions in well trajectory planning, in field development planning, portfolio or business planning, decommissioning, and also in logistics and maintenance. So logistics and maintenance are typical complex planning problems in our industry that most operators are struggling with. Now, why is that? Just to make a comparison with the game of chess again. In a game of chess, there's this amount of board combinations, which explains why it's so difficult to become really, really good at playing chess. Now, just consider a simple maintenance problem, a problem in which you have 80 different maintenance activities, work orders, 80, that you want to sequence in an optimized order. If you want to do that, then this is the amount of different permutations and combinations. Now, 80 maintenance activities is really quite nothing for a complex brownfield operation that most operators use. They have hundreds to thousands of different work orders. So you can imagine how difficult it is to plan your maintenance activities in an optimized fashion, and how much value is left on the table if we don't use the right tools. And if you don't plan well, then that's quite expensive. So this is based on a study by Bain & Company for a brownfield North Sea operator. And you see that this difference between planned maintenance hours and actual hours is quite significant. And that leads to overruns, to late startup of your asset, to rushed and expensive material orders, to operations under time pressure. And in general, that leads to an increase in cost and a reduction in safety on the asset itself. This is just the next 3 slides are based on an actual example, an actual use case we did for a southern North Sea operator. Their problem consisted of a number of elements. One of them is scale of the problem. We talked about the number of permutations that 80 maintenance activities have. This operator had 9,000 work orders to sequence in a certain order on 10 unmanned installations in the North Sea. So a huge scope, a huge scale to optimize. Then there's these changing conditions that you have to deal with in maintenance planning. Inspection results can lead to a change in your portfolio. There can be production upsets that need to be accounted for. Then there's these different opinions. We talked about it already. There's opinions about production safeguarding. There's process safety. There's overall reductions in backlog. Minimizing cost is always on the table. So these competing business drivers make it very difficult to come up with an optimized plan. And finally, there's competition for resources. So this particular operator had a single workboat to service these 10 unmanned installations. And all of the different stakeholders want those same resources. So you have to make choices, you have to optimize. Now, how is this being done today? Most planning teams have an Excel spreadsheet to try to work this out. And it's an Excel spreadsheet to work out a problem that is significantly more complex than a game of chess. So you can imagine that there's a significant amount of value being left on the table. And we can do much better if we use artificial intelligence. So what we have done is we've translated the planning game that the planners play every day into a game that an AI assistant can play. And the assistant needs to make a couple of relatively simple decisions. It needs to decide to which location the boat goes, how long it stays at that location, and which work orders it needs to execute during that time frame. And then it needs to decide to which location it goes next. And if it plays this game thousands and thousands of times against itself, adhering to all the rules and the constraints that normal planners use as well, then it becomes really, really good at playing this game. And it can develop optimized strategies for different scenarios. Now, these scenarios we then present in a dashboard so that planners can facilitate decisions around the plan. A typical dashboard, and this is a simplified version that is on our website that you can play with yourself, is having a number of KPIs, so decision metrics at the top. Here you see, for example, the percentage of safety critical scope completed, the number of work orders in backlog at year end, total production at risk at year end, total number of work orders completed. All of these metrics that are important for the different stakeholders in the maintenance game. Then there's a few other visuals that you can think of: crew efficiency, the total work in the portfolio. You see the vessel timeline here for the next 12 months. And towards the left, you see these different opinions. And in our dashboard, because the AI has developed all of these different strategies already, you can start playing with these different opinions. So if you find process safety the most important thing, then you can flip the switch, and the AI gives you a plan that is optimized for process safety. So it will execute 100% of the safety critical scope. However, that is coming at a trade-off to your total work orders executed. If you want to reduce backlog, you will be able to execute more work, but at a trade-off of safety critical scope. So in this way, you can really visualize the different trade-offs and make much better decisions. So two things that this enables: one, the plans are much more efficient, much more optimized compared to a manual planning game. So we've seen increases in crew efficiency of 30 to 40%, which is significant and would allow operators to reduce their backlog. And secondly, it changes the ways of working, whereas the current process is very often opinion dominated and therefore quite inefficient and frustrating for the people involved. Here we make the process more data driven. Opinions are translated into metrics and into different plans through which the decision maker, for example, the asset manager, can make much better and quality decisions. Now, as a final message, I'd like to leave you with this quote. This is a quote by the European champion in Go, whose world ranking really skyrocketed after he started using AlphaGo, Google's AlphaGo, to train himself. Now, if this is the effect of using AI on somebody who's already quite good at his game, just imagine what this could do to your asset if you start using AI to help you make better planning decisions in maintenance, logistics, or any other area. Thank you.
Thank you, Norbert, for a very interesting presentation with regards to AI in basic oil and gas industry. I want to ask the audience again that they can ask any questions that they want from Norbert and also Diederick on the chat box functionality that is available on the right-hand side of the screen. Please ask your questions. I can see there's a question here from Flor. I read out the question. Does this system also take into account the most efficient way of transferring the personnel? So I leave it out to you, Norbert.
Yeah, good question, Fleur. So we can set up the game for any different logistics fleet you have, or kind of sub functions in that fleet. And indeed, transferring personnel could be a non-productive time for many operators. And if there's a more efficient way of doing that, then this could be embedded in the game. And we can test that against other means of transferring people, see what works better and at a lower cost. So this is relatively easy to set up.
Thanks for the answer, Norbert. There is another question. I'll be quick. I read out the question loud again. How would you compare a planning system like Primavera run by an integrated planner with your system?
Yeah, it's a good question, Eric. We get that question a lot. So Primavera doesn't optimize plans. What we provide is a solution that sits in between the maintenance management system, for example, SAP, that holds the full portfolio of maintenance work orders, and Primavera, which is currently dominated by Excel. So we provide an ability for planners to optimize plans and to facilitate decisions prior to recording them in Primavera as part of the integrated activity plan. I hope that answers the question.
Thank you very much for that precise answer, Norbert. I'd like to ask basically everybody to come online so we can wrap up this presentation. Before I kind of say the last words, I want to point out the ability to guys to be able to go through the TechnologyCatalogue.com if they have any questions, and contact both of you gentlemen through the TechnologyCatalogue.com web platform, and they can also send us an email to info@deploymentmatters.com. We'll put them in touch with you. But once again, before ending the presentation, I wanted to really thank you guys. Thanks Norbert, thanks Diederick for amazing presentation, and I hope our audience also enjoyed the presentation as well. Thank you guys. Have a good evening.